Assalamualaikum and good afternoon. Today I want to present about my mini project which is consists two topic which is word plot, lead and lag compensator. First, let me introduce my team member. First is me, Fatin Natasha Rina, and my partner is Nick Nur Isma Christina. Introduction. A word plot is a graphical representation of a system's frequency response, which describes how the system responds to different frequencies of input signal. The purpose of word plot is to visualize the frequency characteristic of a system, particularly its gain and phase response. Lead and lag compensator are two types of frequency domain compensator used in control system to improve system performance and stability. Transfer function. Question asks us to create one value of k, two value of poles, and three value of 0. So we decide A is equal to 2, B is equal to 4, C is equal to 4, D is equal to 5, and E is equal to 2. So here is our transfer function. The next is amplitude response and phase response. These two response have same step but different in some step. The first step to do this amplitude response is rewrite the transfer function in a proper form. Second, separate the transfer function into its constituent part. Third, draw the Bode diagram for each part. Fourth, draw the overall Bode diagram by adding up the result from part 3. The difference between the amplitude and response is, you can see the table. The amplitude is 20 at the 0 and negative 20 at poles, while at the phase response we use positive 45 at 0 and negative 45 at poles. Before get the equation for the amplitude response, we need to replace the S to the J omega and get the equation. Then the equation for the amplitude is to 20 log something, but for phase we no need to change in 20 log in log form, but we need to change it to the degrees form. Next is word plot. Word plot is a method that we combine the amplitude response and force response in the one graph paper. Select result. How do we know the graph that we draw at the previous that is correct or not? We can run it into the Sealab software. So here's the result of the Sealab that we run, and the result is same with my graph that we draw in the previous step.
In order to solve the lead compensator, there are a few steps that we must follow. The first step is we need to find the phase margin and gain crossover frequency. And for the second step is we need to find the Vmax, which is required addition of the phase margin and add safety margin. The third step is we need to calculate for the alpha. The alpha will be used in the formula of the gain crossover frequency. And then we need to rewrite the lead network transfer function in the GCS form. Lag compensator. There are a few steps that we must follow in order to find for the lag compensator. The first one is we need to find the frequency for our new phase margin. And the next one is we will make this frequency our new gain crossover frequency, reduce the gain to 0 dB. And the next step is the reduction of gain is 20 log alpha. From here, we can determine the value of alpha. And then we put the 0 1 decade below. We put 0Z 1 decade below. And then we can find tau from the Z. And lastly, we need to rewrite the phase lag network based on the formula of transfer function GCS. From the question 3 and 4, which one is the better one? For our mini project, we have decided that lag is better than the lead compensator. It is because the lag compensator, the lag phase margin is equal to 127.93, which is close to 132. Meanwhile, the lead compensator is equal to 98.54, which is too far from 132. Overall, the board plot is useful tool for engineers to analyze and design system with desired frequency response. It provides insight into how the system behaves at different frequencies, allowing engineers to optimize its performance for specific application.